Welcome back to Your Menopause Your Way. I'm Menopause Taylor, the gynecologist who is on a mission to teach you everything you deserve to know about menopause and your options for managing it. We are in the midst of a big unit on breast cancer, and this is video number 368. It's the 13th video in the unit. I systematically present everything step by step to ensure your understanding. And since I do not address hereditary breast cancer in my book, you need to watch this video for this particular topic. Last week I discussed hereditary versus non-hereditary breast cancer in general. Today I'm going to present the specific genetic mutations involved with breast cancer. This is very, very important. Just because a breast cancer is caused by a genetic mutation does not mean that all hereditary breast cancers are caused by the same genetic mutation. There is a whole bowl full of them, but most women are completely unaware of the various genetic mutations for breast cancer. And since they do not all carry the same degree of risk or warrant the same management, you need to know about them. Do you have any idea how many different genetic mutations there are for breast cancer? Most women are only aware of the two most common, known as the BRCA genetic mutations, or BRCA. But most do not understand much about those either. So you're not alone if you feel uninformed, and this video will change that. So settle in and pay attention to this tutorial. I'll start with the very basics as usual. In the last tutorial, you discovered that only 5 to 10% of breast cancers are hereditary. Hereditary breast cancer means that you inherited a gene that increases your risk for breast cancer from one of your parents. Recall that you inherit one set of chromosomes from your mom and another from your dad. They each donate 23 chromosomes to you. And the chromosomes are identified by numbers 1 through 23. So when discussing genetic mutations, it is common to identify the chromosome number on which the genetic mutation is located. You might have a certain gene on chromosome 10, and if that particular gene is a mutant gene, the resulting genetic mutation is on chromosome 10. The most familiar genetic mutations for breast cancer are BRCA1 and BRCA2. The acronym BRCA is for breast cancer. BR is for breast, CA is for cancer. BRCA1 is located on chromosome number 17, and BRCA2 is located on chromosome number 13. Both BRCA1 and BRCA2 are breast cancer susceptibility genes. Most women have the misconception that if you have the BRCA gene, you have an increased risk for breast cancer. But they don't understand basic genetics. Everyone, both males and females, has 2 copies of the BRCA genes. In fact, we all have the very same genes on all our chromosomes. What differs is whether a particular gene is defective or mutated. So we all have 2 copies of the BRCA1 gene, and we all have 2 copies of the BRCA2 gene. Normal BRCA genes provide instructions for making a protein that suppresses development of breast cancer. So normal BRCA genes are red lights. But when there is a mutation in one of your BRCA genes, there is failure to suppress development of breast cancer, and you have a much higher likelihood of getting it. BRCA mutations increase your risk for more than just breast cancer. They also increase your risk for ovarian, fallopian tube, and peritoneal cancer. And they increase the risk of breast, pancreatic, and prostate cancer in men. BRCA2 increases the risk of melanoma in both men and women. So the effects of mutant BRCA genes are not limited to just breast cancer. So, how common are BRCA mutations? Well, they occur in 1 out of 300 to 500 individuals in the overall population. And they increase your risk of breast cancer by 45 to 65% over that of the general population. This brings the total risk of breast cancer due to a BRCA1 mutation to between 65 and 85%. And it brings the total risk of breast cancer due to a BRCA2 mutation to between 45 and 85%. Now, you've probably heard that certain groups of women have a higher risk of carrying a BRCA mutation. And this happens to be true. The most commonly cited group having a higher likelihood of carrying a BRCA gene mutation is Ashkenazi Jewish women. Statistically, 2.5% of Ashkenazi Jewish women carry a BRCA gene mutation. But their mutations are typically confined to just one of 3 specific spots on the actual BRCA gene. And this makes genetic testing for those mutations much easier. And for these women, the risk of getting breast cancer is 29 to 56% before the age of 70. Another group of women with a higher rate of BRCA gene mutations is Black women. And they have an increased breast cancer risk of 28%. But there are gene mutations for breast cancer that have nothing at all to do with the 2 BRCA genes. And most people know nothing about these other non-BRCA genetic mutations that increase the risk of breast cancer. There are actually 7 others. And while they are not nearly as common or significant as the BRCA gene mutations, I want you to know that they exist. I will not go into detail on them other than to place them into risk categories indicating how much they increase your risk of breast cancer. 5 are in the high risk category and 2 are in the moderate risk category. And most have what I call a code name as well as a recognizable disease name. I'll give you both. The high risk category consists of the following: TP53 or Li-Fraumeni syndrome, P10 or Cowden syndrome, STK11 or Peutz-Jeghers syndrome, CDH1 or hereditary diffuse gastric cancer syndrome, and PALB2 or partner and localizer of BRCA2. These high-risk mutations carry a lifetime risk of breast cancer on the order of greater than 50%. The 2 moderate risk genetic mutations for breast cancer are ATM or ataxia telangiectasia and CHEK2 or checkpoint kinase 2. These moderate risk mutations carry a lifetime risk of breast cancer on the order of 25 to 50%. The significance of these gene mutations lies in the fact that their presence will increase the incidence and probability of hereditary breast cancer. So let's talk a bit about genetic testing for these gene mutations. Genetic testing for any of these mutations determines whether or not there is a specific mutation in one of these genes. It does not determine if the gene is present, as most people imagine. But there are multiple problems with gene mutations and their effect on breast cancer risk. There are problems with the statistics. There are problems with our knowledge about these genetic mutations for breast cancer. And there are problems with the extent to which they increase your risk for breast cancer. All these problems stem from the fact that studies on these mutations are not very accurate. And the reasons for the inaccuracy are numerous. First, families vary in size. So it's difficult to assess degree of risk in a very small family with few subjects. Second, because there are limited numbers of families to study, most of our knowledge comes from specifically selected families with individuals who were diagnosed at very young ages. And this means that some of the increased risk attributed to genetic mutations may actually be due to other factors. Third, relatively few women with genetic mutations for breast cancer have been studied. This means that all the data comes from very small studies on very small groups of women. Fourth, even within the small groups of women that have been study subjects, there have been multiple different mutations within the groups rather than just the one mutation under study. We call this heterogeneity. I talked about heterogeneity in the video 366 on risk. You learned that you have to study only one thing at a time. If you want to study peaches, you have to make sure you do not include any prunes. Likewise, if you want to know your true risk due to any particular genetic mutation, you have to use data that only includes individuals with that particular genetic mutation. And unfortunately, that kind of pure data is unavailable. So most of these genetic mutations are not studied in isolation, and the result is that the data from them is imprecise. Fifth, some of the risk data are based on women who had both breast cancer and ovarian cancer rather than just breast cancer. And having two cancers instead of just one can change everything. So do not take these risk estimates as absolute or completely accurate. When you do, you overreact and make them a bigger, scarier problem than they actually are. So here's a little chart of these different genetic mutations for breast cancer. All I've done is create two categories in the first column, high risk and low risk. The second column bears the acronyms for the breast cancer genetic mutations. The third column lists the actual disease names. And the fourth column depicts the degree of increased risk for each. The chart is available via the link in the description box and at menopausetailor.me. So, what makes a doctor suspect that you might have a genetic mutation for breast cancer? Obviously, women do not routinely get genetic testing for breast cancer mutations as part of their regular lab work. Instead, it's usually a case in which there are certain red flags that raise the suspicion of a genetic mutation. And these red flags fall into two categories: your personal history and your family history. Personal history factors that raise the suspicion of a genetic mutation for breast cancer are breast cancer before the age of 40, bilateral breast cancer, meaning in both of your breasts, and a history of both breast cancer and ovarian cancer. Family family history factors that raise the suspicion of a genetic mutation for breast cancer are Ashkenazi Jewish heritage, male relatives with breast cancer, relatives with both breast and ovarian cancer, relatives with 2 different kinds of breast cancer, and relatives with breast cancer before age 50, in particular maternal first-degree relatives, which means your mother or your sister. Now, given the fact that there are these specific factors that raise suspicion of a genetic mutation for breast cancer, you would think that doctors would offer genetic testing to women who have any of these factors. That would enable those women who want genetic testing to utilize the results to manage their menopause in a way that takes their increased risk of breast cancer into account. But that is not what's happening. Instead, doctors treat women who have any of these factors like they have had breast cancer themselves. They encourage increased screening, deny use of HRT, and even subject these women to chemoprophylaxis. Back when I mentioned the distortions in the world of breast cancer, this is one of the things to which I was referring. Do you remember the story of this classic novel called The Scarlet Letter? It's about a woman who commits adultery during the 1640s in Puritan, Massachusetts. And she is humiliated by having to wear the scarlet letter A for adultery on her chest. The A announced to everyone that she had sinned, and it condemned her to a life of suffering. Well, much of what is going on in the world of breast cancer is like that now in the 21st century. In other words, women who have a mere possibility of carrying a genetic mutation are labeled and treated as if they definitely have the mutation. But instead of a scarlet letter A, they're labeled with the fuchsia letter B for breast cancer. I mean, why treat a woman like she's wearing the fuchsia letter B for breast cancer when she herself has never had breast cancer? The humane thing to do would be to offer genetic testing to women. Those who wish to take advantage of it would know for certain whether or not they have a genetic mutation that increases their risk for breast cancer. And they could manage that accordingly. Those who do not want genetic testing for breast cancer could carry on as they please. But to use these factors to terrify women or deny them choices is just plain wrong. Having a gene or a family history of breast cancer is not the same thing as having had the disease yourself. So a gene is not a disease, and you should not manage it as one. Now, as always, your genetics is not the whole story. When it comes to your personal actual risk for breast cancer, you have to add all the other risk factors for breast cancer on top of any genetic predisposition you may have. As I've taught you previously, there is something called epigenetics. Epigenetics is how your genes interact with your environment and lifestyle habits. So your environment and lifestyle habits could serve to increase your breast cancer risk, or they could serve to decrease it. So do not assume that just because you have a genetic mutation for breast cancer that you are destined to get it no matter what you do. And you know I'll be giving you videos on all the things you can do to reduce your risk for breast cancer. Next week, I'll present the long list of risk factors for breast cancer before delving into each one specifically. Okay, so what you've learned today is that there are multiple genetic mutations for breast cancer. The most common and most high risk are the BRCA1 and BRCA2 genetic mutations. BRCA1 increases breast cancer risk by 65 to 85%. BRCA2 increases breast cancer risk by 45 to 85%. Ashkenazi Jewish women with BRCA mutations have mutations on just one of 3 specific spots on the BRCA gene, and they have an increased risk of 29 to 56%. Black women have an increased risk of 28%. Other mutations include high-risk mutations, which increase breast cancer risk more than 50%, and moderate risk mutations, which increase breast cancer risk between 25 and 50%. If you have a personal or family history that is suspect for a breast cancer genetic mutation, you should consider genetic testing if you would use the information to manage your menopause. And regardless of your genetic status, you still have to consider all the risk factors for breast cancer in general. So I will see you next week to present the risk factors for breast cancer in general. I do hope you go to menopausetailor.me between now and then to schedule a consultation, and I do hope you've already subscribed to this channel and my newsletter. And I hope you like me enough to follow me on social media. That would be Facebook, Instagram, Pinterest, and Stories. Bye for now!